morning, everyone, and let's get to kind of showing the row. I want to kind of take off, hopefully, from where we left last time and look at it. Whoa! I don't know what it is. Excuse me. Just going to mute you all in case whatever that was happens again. There we go. So if you want to answer, just hit the spacebar. So we're going to look at area under curve. And there is 3 different kinds of questions I want to deal with. The first type, I guess in no particular order, but the first type is we're going to look at questions where you get a graph, and we're going to find the area under the curve when the information is in the form of a graph. The second situation is that we're going to be finding the area under the curve, but we're going to be told the equation. And the third situation is we're not going to be given a graph at all. We're just going to be given a table with the necessary numbers on it. And we're still going to find essentially what the area under that graph would be. And in different contexts, that area under the graph, when it's a table, represents a particular thing. For instance, if this was time against velocity, does anybody know what the area under a time velocity curve is? The area under a time velocity curve. What does it represent? Yes. So in things like this, you'll be asked to find the distance traveled. Or it might be a table where it's the rate at which water is shooting out a tank. You're going to be asked how much water, the total amount of water. So graphs, functions, and tables. And I don't know what I'm going to say. Let's start with functions. Let's suppose we have a question and we're being asked to find the area under a curve, but they give us the equation of that curve. So let's suppose we've got this guy. He's y equals x cubed plus 1, and it starts at 2 and it finishes at 4. And that's the fella that we're being asked to find the area under the curve. Now, in a question like this, you would be told how many strips. And you remember we use n equals 4 represents the number of strips. So we're being asked to estimate this using 4. So far, so good. We're going to go 1, 2, 3, 4, something like that. Pretend they're the same size. We would also calculate the width, which is that distance from here to here, which is called delta x. And we get that by this general formula. In this case, it's going to be 4 take away 2 split into 4 equal parts. And that tells me that delta is 0.5. Now, I want to add some other things into this kind of question. Do you recognize that this curve is an increasing function? Right, as x gets bigger, the value gets bigger. Now, I want you to imagine that if a function is increasing, that we actually can find a range of values where the true answer is going to exist. I'll show you what I mean. If a function is increasing, in the region A to B, because we typically call the start number A and the finish number B, if it's increasing, then this is true. If I find an R4 and I find an L4, one of those two is going to be an overestimate. It's going to be bigger than the real answer. And the other one's going to be an underestimate, which is less than the answer. So let's see what we get if you are dealing with an increasing function. Well, if I do the left one, right? So if you take the first strip and use the left-hand side, you get these guys. And I hope you agree with me, wouldn't these 4 rectangles add up to an area that's less than the area of the under the curve. So that means this fella, the left side one, is an underestimate. And if I did, for the same strip, I used the right-hand side to get the height, you get these green guys. And can you see that every single one of them is bigger than the area that we're trying to get? So wouldn't that be what we call an overestimate? Does that make sense? That if a curve is increasing, then the left and right estimates, one of them will be an overestimate and the other will be an underestimate. Let's start calculating. What you do in these questions is you set up a table of values. And you start at the first number is 2. And the interval in this case is 0.5. So you go 2.5, you go 3, you go 3.5, and you finally finish at 4. Now, in this case here, the function is very straightforward, right? So I could do these in my head. I'm not going to. I could do them individually on a calculator. I'm not going to, because I'm lazy and careless. So I'm going to use the shortcut on the calculator, which is the tables feature. So I'm going to go y equals, oops, that's for a different class. Okay, back to what we should be. I'm going to go y equals, I'm going to type in x cubed plus 1. I'm going to do second table. I'm going to start at 2. Delta x is 0.5. I'm going to do that. And it's set up as auto and auto. So you see it's all set up for me. And then I can just go second table. And now I've got, I'll put it in red, I think. I've got all the answers I need and some extra. I have 9, 16.625, 28, 43.875, and finally 65. That's kind of the step one, right? That's kind of the first thing you really need to do. You need this table before you can calculate any of these things, right? Then what am I going to do? Well, I can do R4 or L4. It doesn't really matter which one I'll do first. Let's do L4 first. And it's going to be delta x, all these guys added up. So essentially, the interval is 0.5. And since we're doing the left one, don't we pick the 4 on the left? So it's going to be the width is 0.5 with the height of 9 added to this height, added to this height, added to that height. Whoa, just squeeze that in. And then I'll go to my calculator. And I'll go 0.5 times a bracket, 9 plus 16.625, and then the other guys. And the answer I get is 40.85. 48.75, I should say. No, I did that a bit quick, but are you comfortable with the button pressing? Because that's really all you're going to do. You know, multiplying and adding a whole load of stuff up. Now, since this is an L4, isn't this an underestimate? Can you see it's the red guys, right? It's an underestimate. So I'm now going to do R4. And R4 will be 0.5, but it will be those guys. If you turn it on its side, you see it's the 4 on the right. And so it's going to be 16.625 plus 28 plus this ugly number and finish with a 65. So it's 0.5 times all those numbers I just said. Finish with 65. And we get 76.75. And you can see that's much bigger, and it's not a surprise because isn't it an overestimate? So far, so good. Right. Now, since I have that piece of information, I can say that the true area under the curve is, in this case, less than R4, but bigger than L4. So it's somewhere in the region of 48.75. And it could be anywhere up to 76.75. Are we comfortable with the logic of why that makes sense? Why we're allowed to say, I don't know what the answer is, but I can guarantee it's definitely between these two guys. If the function was a decreasing function, right? This was an increasing one. Imagine we did the same thing with a decreasing function. What would we be able to say about the left and the right? Well, we'd be able to say the exact same thing, but wouldn't they switch places? Wouldn't the right one now be an underestimate? And the other one, the left one, would be an overestimate. And after you calculated the two, wouldn't you be able to tell the little one's the underestimate and the bigger one's the overestimate? So it wouldn't be too hard to figure out which one was which. But you might get a question where they don't ask you to do anything, they just ask you to say which one's an overestimate. Right, so you would just look at the picture and say, now, if you have a function that goes up and down, you can't say for sure either of these, right? You just get two answers. One might be better or worse than the other. You can't really tell unless you look at it and say, well, it looks more like the right's got less error in it. And so maybe that's a better estimate. That's about all you could say. So far, so good. Now, let's introduce a new fella. It's called the midpoint. And we would use M4. And the midpoint 4, and I'll use my picture here to kind of show you how it works, is also a rectangle, but it's a little bit different as well. You start at 2, you finish at 4. There's the first guy, there's the second guy, there's your third guy. That guy's 2.5, that's 3, that's 3.5, right? That's the guys we use for this table, right? If I take one strip, the first strip, we could use the left-hand side, which get me this. We could use the right-hand side, which would get me this. But for the midpoint, you use the middle of the interval. And you find the height at the middle of the interval. And I don't have any more colors to play with here, so I guess I'll do it this color. Do you see that this rectangle is better than either the left or the right? Let me take a clean one. See this one here? This one here? If I chose the middle, right, the X value right there, to get the height, do you see that the rectangle I use has a little bit under and a little bit over? Don't they almost kill each other off, cancel each other out? Can you see that rectangle is probably going to be, in general, a much cleaner, better estimate than the other two? So we're now going to do that same curve, the x cubed plus 1, and we're going to set up the calculations that you would use doing a midpoint. So here's my table. X is going to be my f of x. I might as well use these numbers. You know, the first interval starts at 2 and then finishes at 2.5. Agreed? 2 to 2.5. So the middle between those two, wouldn't it be the average of those, halfway between them? And so the first midpoint number is 2.25. Are you comfortable about how I got that guy? Now, the good news is that the strips are still going to be delta x wide. Great. So that means that the next number is just add 0.5, just add 0.5, and just add 0.5. Do you see that when you do a midpoint, you have to create a new table? Don't you use the same table for a left and a right, but you have to create a slightly different table for the midpoint? Secondly, do you notice that the midpoint table only has 4 numbers? You notice this table has 5 numbers, but you either use the first 4 or the last 4, right, for left and right. But here you have 4 numbers. And how would I get that from my calculator? Well, it's kind of pretty much set up. So I'll go table setup, and I'll start at 2.25. That's really the only change I need to make. Everything else can stay the same. And then I'll go to second table. And if I didn't already know that, can you see I've now got all the values of x as well? And so what do we get? We get 12.391. We get 21.797. We get 35.328 and 53.734. And so to get the midpoint 4, it's 0.5, the width, plus all those guys. Okay, let's see what that looks like. It's going to take me a while to do this, and I'm not very good at multitasking, so I probably won't say much. And I get 61.625. So let's put those guys together. Our estimate using the left side was 48.75, and that was a bit in the low side. If we used right 4, we get an answer which we know is a bit bigger than it probably is going to be. And then we've got midpoint 4. Would you agree it's not a surprise that midpoint 4 is some number between those two extremes? It happens to be, in this case, 61.625. And you might think that if you just added these up and averaged them out, you'd get this number. But typically you don't. Right. What I can say for sure is that if I have 3 to pick from, I would always pick this one, because it tends to be, in almost every situation I can think of, a much better estimate than any other of these 2 choices here, at least. Does that seem reasonable in the midpoint? And the midpoint doesn't care if it goes up or down, right? Left and right don't care if they go up or down, but if they go up and down, you can't do this over underestimate thing, right? That's the only difference. It's not uncommon, as long as you've got a decent number of strips, that this guy here is pretty bang on. You know, if you've done about 10 strips, you probably get the answer good to about 2 decimal places. It's pretty accurate. Pretty good. So that's my first of the 3 techniques. If someone gives you an equation and they say, look, I want to know the area between whatever and whatever, right, from 2 to 4 in this case, do a table left and right, do a slightly different table for midpoint, call it good. Seeing some nods, can we call that kind of question done? Because they are boring as heck, I tell you. They drive me. You have to know how to do them, but it's not my favourite thing. So next one I'm going to do is suppose they just give you a graph, no function, just a picture. And we want to take this thing, right? And we want to get a midpoint or a left or a right, whatever it is they're going to do. Now, for that question, I'm actually going to use the homework because it's just a lot easier. And someone showed me a really cool trick that I forgot all about. So this is homework question number 1. Right, so do you see it's a decreasing function? Pretty obvious, you can see it. Just closing some windows here. And I want to set up, well, what do I want to set up? I want to read values from this graph. 5 rectangles, so I guess they've just told me that n equals 5, haven't they? I'm writing that down. And what else have they told me? Well, we are being asked to find a lower estimate. Isn't a lower estimate just another name for an underestimate? They call them underestimates in different questions as well. So do I want to find an L5 or an R5 in this graph?
An R5.
Okay, so if you pick the right-hand side, you see the rectangle you get is smaller. Do you agree? R5. So I'm writing that down, R5. Okay, so when I finally get the answer, it's going to go in here. Now, if you click on this picture, do you see that they're really nice and they tell you all the coordinates? So I don't have to guess, I guessed. And then someone nailed across said, hey, if you click on it, you get this. So I'm going to set this table up and then you'll see it. So I'm just going to tell you the numbers we're going to use. Right, now this particular one is going to start at 0 and finish at 10, right? So can you imagine A is 0 and B is 10? And if you figure that out, each strip, because you're going to do 5 strips, ends up being 2 units long. Can you imagine that in your head? You're going to go 0, 2, 4, 6, 8, 10. Does that make sense? So when I click on this table, I don't care about some of the numbers. I only care about the value of the function at 0, 2, 4, 6, 8, and 10. And at 0, the function's value is 0. At 2, it's 3. At 4, it's 1.8. At 6, it's 1.1. At 8, it's 0.7. And at 10, it's 0.4. I'll now zoom back to what I was doing on my paper. Are you comfortable about how I got these values based on the information from the graph? 5 strips, and we're going to get the underestimate, right? We're going to get the R5. A is 0, B is 10. That's how I figured out delta was 2. And now I'm going to use, oops, I almost did it wrong. Let me fix that. I'm going to use these ones here. And I don't know how to make that go away. Go away. There. So R5 is going to be delta x 2 times 3 plus 1.8 plus 1.1 plus 0.7 plus 0.4. Try this in my head. 4.8, 5.9, 6. Oh, I don't like that. 4.8, 5.9, 6.6, 7. I don't know why whole numbers bothered me there. I was hoping for a decimal, I guess. You know, I can't count. Does that look okay, guys? Got a nod, I'll use it. And that answer goes into the first box. So I'm putting in 14 here. And then I'm going to do submit answer, although you can't see it. I'm going to check that I did it correctly. And I did, so I'm cool. Now, I'm going to, I guess I have to jump around here. It's a bit unfortunate, but that's just the way things have to be. Right, so there's the right answer. You see, I've checked it, 14. Now, there are 4 pictures, and they're saying which one of these 4 diagrams represents what R5 would look like. Now, it's definitely not that one. Would you agree there's far too many strips? There's more than 5. And it's definitely not that one, because there's definitely more than 5. Is it this one here or the one below it? Which one is R5? Correct, Matthew, it's the one below. And that's all you do for that. And then we would go through the same thing. And this time it says by reading values from the given graph, use 5 rectangles, find the upper estimate. So I guess the upper estimate is L5, right? So let's go back and look at what the calculations for doing that would be. And it's going to be 2 times those 5 guys, right? And that's going to be 0, add 3, add 1.8, add 1.1, add 0.7. And that's 2 times 3, 4.8, 5.9, 6.6. Double check that. 4.8, 5.9, 6.6. And that ends up being 13.2. Pretty close, aren't they? Don't we know that the right answer is probably 13 point something? Right, we've got an over and an underestimate. We know it's somewhere in that range. I want to show you a little trick of the trade. When you're doing small strips like right and left 5, this trick isn't worth it. It's not worth the effort, right? It's not that hard to do 5 strips. But if you're doing 10 or a lot of strips, this little trick is helpful. You have to get the first one the long way. There's no shortcut to that. But I can actually get the answer to L5 by using my answer to R5. Because when you look at the two of them, aren't they almost the same calculations? What's the difference? Well, this guy has a 3 and this guy has a 0.7. So if I wanted to get the answer to L5, I take the answer to R5, which is 14. I then take away this guy, which is 6, right? 2 times 3 is 6. And in its place, I'd add the new guy at the end. So I'd add a 1.4. Now, if you take that and you get that, what do you get? 6. That's good up there.
The difference is actually the 0, which is supposed to be a 5. Or the 0 versus the 0.4, but the 0 is actually supposed to be a 5 if you look at the graph.
I switched. Ah, okay. The trick works if you do the bloody question correctly. My apologies. Darn it, that was annoying. Right. I should warn you that I am careless. And so if you notice that I've done something wrong, like I added something at the wrong place, then tell me. The process is correct if you do it with the right numbers. Now, I would like to show you the third one, which is the table. And then we'll go back and look at some, maybe go over another example, perhaps of that graph one. That would be probably a good idea. So let's do a table one. And I'm picking one straight out the homework. And I'm going to pick one that's got not to be too horrible, this one. Okay. So this one is a version of question 6. And they have the time and the velocity. And it's 0, and it's 0.5, and 1, and a 1.5, 2, 2.5, and then it finishes with 3. Okay. And then the velocities are 0, 5.7, 11.2, 14.1, 18.8, 19.4, and 20. And the question asks us for the lower and the upper. Now, this table contains all the information we need. We just have to suck out what we're looking for. What are we looking for? Well, the first thing I want to look for, we typically call delta x, but since this is time, I'm going to call it delta t. Isn't delta x or delta t in this case the width of the rectangle that's going to be used? Now, if you look at this table, do you see that from one number to the next, it's 0.5? So I know this guy is going to go 0.5 and some stuff. And I know this one is also 0.5 and stuff. Now, they're not calling it an overestimate or an underestimate, but that's essentially what these are. This is an underestimate and this is an overestimate. Would you agree that this particular function is increasing? So if you imagine what it would look like, it would look something like that, right? Okay, which one is that going to be? Oh, before I do that, there's 1, 2, 3, 4, 5, 6, 7 data points. Now, when you've got 7 numbers, does that mean you're going to get an R7 and an L7? Or are you only going to get an R6 and an L6? If a table has 7 numbers in it, which are you going to be able to calculate? 7 one or the 6 one?
6.
6. Have you noticed that when we did, see when we did the table, didn't you ignore the bottom one or ignore the top one? At least if you did it right, you would. So I know I'm going to use an R6 or an L6. Now this is increasing. So if you imagine one rectangle, can you see the left one is the underestimate? So the under one is going to be L6 and the upper one is going to be R6. So that's us. We've got everything in place. It's really just a matter of plug and chug now. So let's see what the numbers are. For the left 6, we're going to use those guys, right? The 6 numbers on the left. So that's going to be 0, 5.7, 11.2, 14.1, and 18.8, and lastly, a 19.4. And if you want to do the upper one, you can use those numbers. I'm going to write those ones down. I'm going to try and do my shortcut, and this time hopefully get it right. So go to your calculator, and it's going to be the width, which is 0.5 times these heights. So 0, 5.7, 11.2, 14.1, 18.8, and finish with a 19.4. And the answer I get is 34.6. Now, if I wanted to do the R6, wouldn't I just go 0.5 and add those all up? I mean, it's not too onerous, but I would get the answer, right? But let's look at the shortcut. Don't you lose the first one and gain the last one? You agree? You lose this one and you gain that one. So that means I can just take my 34.6. Technically speaking, take away 0.5 times 0, but I'll put it in for argument's sake, right? 0.5 times 0, which is nothing, right? So you take away nothing. But you add on that fella. You add on a 0.5 times 20. You see what I'm doing there? Subtracting 0.5 the first one and just adding 0.5 the last one. You know, just a trick to reduce my workload. And the answer I get is 44.6. Okay, how confident are you that I didn't screw up there? Because I am never confident when I do anything like this. I'm going to go in and we're going to check it out. So according to what I just did, this should be 34.6. And this one should be 44.6. And submit answer. Am I good or am I good? Yay, I got one right. The small pleasures. Are you comfortable with this table? In fact, in a lot of ways, isn't the table less work? Because most of the work's done for you. All you need to do is figure out who the delta x or t is, and then do a little bit of adding, and off you go, and you're done. Right, so we've covered the three main kinds, right? You've got a function like x cubed plus 1 and how you would get it that way. You've got a graph which you just read off the points, and we've got a table. Any questions about those three techniques? That's a good sign. I get a chat. Maybe I should have a read because that could be a question. I think someone earlier picked up that mistake. You are correct. I screwed up with one of my numbers in the previous question, and that's what her question was about. Okay, so I think I'm going to return back to one of the graph ones, the ones I screwed up, and see if I can do one correctly. Right. So I'm not. Where are we right now? I think we're in the right place, but I'll have to check. There we go. Well, this is a long question. Okay, here we go. Oh no, that's got a function. I can't use that. That's got a video. I can't use that. Running shorty choices here. They're not that many. Okay, that's a function. Can't use that. Okay, our last guy. And there are only two of the graphs, so here we go. We got a graph here. It's decreasing. They want us to find L6. So if we click on that guy, I should be able to create a table. Let's see where we're going from 0 to 12. You won't be able to see this table until I've written down all the numbers for it. Since we're doing L6 here and it goes from 0 to 12, isn't delta x going to be 2? So I'm going to start at 0 and go 2, 4, 6, 8, 10. So it's going to be 0, 2, 4, 6, 8, 10, and finish with 12. And the values I've got are when x is 0, the function's 9, 2 gets me 8.8, 4 gets me 8.2, 6 gets me 7.3, 8 gets me 5.9, then I go 10, which gets me 4.1, and I finish with 12, which is 1. Okay, that means I can now go back to the whiteboard and finish it off. I think you all know this is not my favorite part of this topic, but it's important, so I need to do it. We're going to do L6. So that's going to be delta x, which is 2. Oh, and by the way, I got delta x by taking the start, take away the finish, and dividing it by 6 strips. So it's going to be delta x times, if you're doing the left one, and this is on its side, it's going to be these guys. The 6L. So it's going to be a 9, add an 8.8, add an 8.2, a 7.3, a 5.9, and finish with a 4.1. Okay, 9, 17.8, 18, 26, 33.3, 38.3, 39.1, 39.2, 43.2. And if it's not right, pretend it is. 86.4. Suppose they ask me for R6. Couldn't I just take this answer, which is L6, subtract that guy, which is 2 times 9, which is 18, and add that guy, which is 2 times 1. So what's the benefit here would be basically taking away 16. So that would get me 70.4. Yeah, I think that was worth it. Shortcut. Now, since we're in the last few minutes, suppose they wanted me to find midpoint 6. I need to create a new table. And the numbers, 6 numbers I'm going to use, 1, 2, 3, 4, 5, 6. Will be a little bit different. Well, if you look at the first interval, it starts at 0 and it finishes at 2. Are you happy about the midpoint would be 1 here? Right, 0 to 2. And then after that, it just goes up in 2s. And though you can't see it, you're just going to have to trust me on this. This guy is 8.9. This guy is 8.5. 7.8. 6.6. 5.1. And we finish with 2.8. So M6 is going to be 2, that's delta x, plus these 6 numbers. And I'm going to do it in my head again, which is very dangerous. 16, 17.4, 24.4, 25.2, 31.8, 36.9, 38.9, 39.7. So here is M6. And this shape is clearly decreasing, right? So can you see this is my overestimate and this is my underestimate and this my best estimate? And does it make sense that this is somewhere between these two? Which you would expect it would have to be. Okay, last few topics. First one, before I forget, say hi in chat. That's attendance been taken now. And while you're doing that, how could I improve the accuracy of, well, probably not so easily this one, but how could I improve the accuracy on the one where you're given a function, the middle one? You know, if I know f of x is x cubed plus 1. What would be the only real strategy I'd have to get a much better answer to the area under the curve?
Rectangles.
Yeah. You know how boring it is to do 10? Do you really, really want to do 100? No. So do you know what you do? you get somebody who's into computing and you say, write me a program. And if you do it for 100, can't you make a computer program do it for 1,000,000 strips? It wouldn't take it that much different in the programming. And then you can do it for 1,000,000,000 strips. Can you imagine you could do it with so many strips that it wouldn't really matter anymore? Wouldn't you be essentially getting the area under the curve? Yeah. For any accuracy that you could ever possibly want. And that is about it. Any questions before we call it a day?